Again, we are ready to get started on our webinar today on creating illustrations from 3D data. Our agenda today is going to be, I'll start off with just going through the general housekeeping rules, a company profile for those of you who are not familiar with our company and what we do, an introduction to the content, and then we're going to be covering some background in 2D and 3D graphics. Then we'll get to the real meat of the webinar, which is one topic will be converting 3D data to 2D, and then 3D to 3D. And then we'll wrap up with a summary and a Q&A session. If you should experience any problems, please use the chat window to communicate with us. All attendees will be muted for the duration of the webinar. Computer audio is a recommended option. There are some associated materials or handouts, PDFs that you can drag and drop to your desktop. We welcome you to do that. Post your questions at any time during the webinar in the questions panel, and then we'll answer all those questions at the end. If we should run out of time, we will get back with you by email. Larson Software Technology is based in Houston, Texas. We've been around since 1984 as graphics technology experts. We develop powerful, innovative graphics software toolkits and end user products based on open standards. We've promoted the CGM usage for some time. We've had a free CGM viewer, which recently we took to a subscription version. For a modest amount, you can obtain a copy of that on our store. We're a developer of the first HTML5 CGM viewer to eliminate the need for plugins. We're a member of the CGM Open Foundation, and generally speaking, our products simplify the graphics workflow for technical publication professionals. So for that, now we will turn it over to David Manick for the body of our presentation.
Thank you, Don. Welcome everybody. Thanks for joining us today. So it's been a busy year for us with webinars. We've done, I think, more than any other year. That's something that's fortunately or unfortunately come out of the pandemic, but we're happy to be bringing this information. It's certainly been a good way for us to communicate with our audience and customers over the past 12 months. So this will be the final webinar of 2020, but we'll be doing plenty more in 2021. So today's, as Don has already outlined, the topic is really about 3D data. This is something we've been really focusing on. Particularly this year, we've had our roadmap for the VizEx Edit product in line for some time, but this year has been really our big push to support 3D, both import and export. So we understand, obviously, the 3D data out there does enable the creation and delivery of technical illustrations, particularly new illustrations, perhaps not legacy. But technical illustration has some very kind of specific requirements, and these are not usually present in CAD systems. So we don't say you can't use a CAD system to create an illustration, but some of the things that you'll need probably aren't going to be there. So there's still going to be a finishing period. In other words, adding things like hotspots, annotations, and not always the quality is great if you go straight from a CAD system. And it doesn't tend to support the file formats that might be required for some industries, particularly aerospace and defense. Also, it could be not the ideal environment to manipulate the model in a fast and intuitive way. So that's something we've been really focusing on to make that as easy as possible. So the objectives really today are really discuss the the points of interest in delivering and also converting 3D data. We're going to really focus on our new product, which is VizEx Edit 3D. We're going to look at converting 3D to 2D. So in other words, creation of a 2D line illustration, black and white line illustration from the 3D data. And also actually converting, sounds a bit strange, but 3D to 3D. So taking 3D from, say, a CAD system and then putting it into a format that's then useful in the web, in an IETM, so a much lighter format and something that's more aligned to delivering, say, maintenance illustrations or disassembly, assembly, repair. So something more suitable for that environment. We'll also look at how we integrate with your workflow, but as with all our products, they do tend to integrate very easily into processes that you might already have in place. So we'll look at what the target formats, both 2D and 3D, because they're obviously different. And at the end, we'll have, as Don mentioned, a Q&A session. So you can ask questions at any time, but we will try and get to them at the end. So just put them in the questions panel as we move forward, and then we'll hopefully get to them and answer them. Thank you. So brief introduction to 2 and 3D. That is a question. Do we deliver 2D or do we deliver 3D? And the overriding driver really in technical publications and more specifically illustration is cost. What's the most cost-effective way of delivering these illustrations? But we also want to give the customer, the best information we can. So there's kind of a trade-off here. We believe, or my opinion is, in the near term, 2D illustrations will continue to dominate because that's probably the fastest and quickest way, most cost-effective way to create the illustrations. That's not only about delivering new, but that's also about the legacy data. So 2D, there's a tremendous amount of 2D legacy illustrations that have to be still revised and edited and maintained. And there's also trusted formats around that. So CGM, SVG, PDF are all good 2D formats for the exchange and also delivery of illustrations. I think the use of 3D, though, is a bit more complex. There's a lot more formats involved, but there is a greater access to that 3D data than there has been in the past. But also, obviously, a lot of the new equipment is being designed in 3D. So there's a good way of actually bringing that data over and us perhaps reusing it in a technical publications environment. So the question is, do you take the 3D and convert it to 2D? Or do you display the 3D information in a usable file format for your customers? And there are many 3D file formats, both proprietary and open. So what 3D formats do we use for the best results? And that's something we'll discuss during the webinar today. So what's the current situation? As I said, I think 2D is still the primary creation delivery method. If you look in percentage terms, there's that huge archive of 2D illustrations. And I think it's extremely unlikely that those legacy illustrations are going to be converted to 3D. And that's probably, again, down to cost. So there's a huge requirement to keep maintaining and editing and revising those illustrations. And that's why we have the standard version of VizEx Edit, which enables you to do that. In the aerospace and defense industry, which is one of our major customers, is that the 2D CGM format still dominates. But we are seeing SVG appear more and more, mainly as a display format. But the specifications still dictate, that's S1000D and ATA, or recommend CGM as the archive format for illustrations. But I think the delivery of 3D is growing. We've seen it in spare parts catalogs, maintenance type illustrations, assembly, disassembly animations. operational and instructional illustrations. So it is growing, but it's probably still equates to a small percentage of actual illustrations that are delivered as part of technical publications. So what does the future look like? I think it will continue for some years to be predominantly 2D, but I think the combination of both 2 and 3 will become more the accepted norm as we go forward. I think new illustrations have the potential to be 3D because the 3D data will no doubt exist. And I think there'll be an expansion in the use of VR and AR, so virtual reality, augmented reality. But I think the costs will determine the uptake of that. And that's not just for the creation, but that's also the delivery of that information. So there's definite benefits to 3D, but there are some dependencies and pitfalls when you and that's probably the cost to deliver that 3D data. The benefits, definitely visually easier to identify parts, view from any angle, animate those parts in 3D, so really good for removal and repair procedures. And you easily reuse the 3D CAD data, so you could update as the model changes in the CAD system. So there's definitely benefits there. The dependencies, is the software available to easily repurpose that CAD data in a cost-effective way? So what are the considerations when you have 3D? If you're going from 3D to 2D, then it's the quality of the illustration that you are outputting. You want it to be good and editable. If it's 3D, you're delivering, will it display on target devices, cross-platform? In other words, going to mobile devices, desktop devices, laptops. You've got to take into account all those different devices and platforms. And some strange one, does the customer still require hard copy? That's still not gone away, in my opinion. So if it's 3D, that's a difficult one to deliver in a hard copy form. So also, what's the cost? How much time will it take to author? Is it going to be longer than usual? Do we have to build that in? Is there a business case required? Do we have the correct software to create that data? And is there a cost to that as well? So 2D, do we continue down the path of creating and delivering 2D data? I think in the short term or medium term, we'll still do that. However, new illustrations will be originated from 3D, so have that potential to be either converted to 2D or delivered in 3D. So I did mention legacy 2D illustrations. As I said, it's very unlikely that they're going to be updated to 3D unless there's a pretty good business case for doing that. And there's a vast amount of existing 2D illustrations. So for us, we're still, one of our primary goals is to update our standard VizEx Edit 2D product to enable customers to revise and edit these illustrations. So I think you have to look into the current delivery mechanism. So will it be electronic or hard copy? That's still going to be a factor when you come to actually create the illustration. And as I said, there will need to be a compelling business case for a 3D conversion on that type of scale. So the first topic we're going to look at is 3D data to 2D. This has been going on for some time. We now have really a tool that we believe that will enable you to do this in a cost-effective way and a really intuitive way. So there's a lot of CAD systems out there. These are just a few of them. Some of the names you've probably heard of: CATIA and Creo, SolidWorks, Inventor. There's obviously others as well, but these are the main CAD systems where design engineers are working. One of the main challenges is choosing a good format to exchange. we'd always recommend some kind of open format. And then you need to repurpose that data to 2D. So some of the CAD systems are capable of doing this, but that means as an illustrator or as a writer, you might need access to that. So we really want to see a separation from the CAD. Let's exchange the file and bring it into a system that's more easy to use than perhaps the overall CAD system that the engineer uses. There's two real major CAD data exchange formats, which is STEP and IGES. And that when I say exchange formats, that's the engineering world where STEP and IGES, particularly STEP, is used. They're really data rich, contain a lot of geometry, so that enables us to get the best quality from when we convert from 3D to 2D. There's obviously other options such as native CAD formats. That's, from our point of view, that's something we may support in the future. But at the moment, we're going to focus on those open formats, which pretty much every 3D CAD system supports. So the target formats, if we're going to convert from 3D to 2D, these are the two that I'm focusing on. But we also, within VizEx Edit, support things like PDF and Adobe Illustrator. But two of the primary ones are CGM and also SVG. So we support others as well, but those are the ones that we might discuss today a bit. So certainly in the specifications-driven environment, things like S1000D, SVG has grown into a significant format, mainly for display of graphics in IETMs. But certainly CGM is still the primary format for delivery of technical illustrations to programs. In the main CAD systems, they could support SVG and CGM, but certainly from a CGM perspective, the quality tends to be questionable, if at all useful, mainly because it will blow the file up. It will contain polylines, so it'd be very difficult to edit downstream. So it's not something we would recommend. You really want to optimize that data if you want to reuse it. So our conclusion is you really be best off with a specific software rather than general CAD system. So this is why we developed VizEx Edit 3D. It imports STEP and IGES files. It will convert them to CGM, SVG, PDF, whatever VizEx Edit supports. The 3D model can be quickly and easily manipulated. We can explode the model. We can achieve the required viewpoint with a hidden line removal, and the result will be a quality 2D illustration, CGM, SVG, whatever format we support. So we're going to do a live demo of the product. So let me just bring up here. So we're now in VizEx Edit 3D. I've actually brought in an illustration already. It doesn't take long to actually, this one takes about 20 odd seconds to import. I thought I'd just bring it in to begin with, just to save some time. We support IGES, as I said, STEP, and we now support VRML as well. So we support all those three formats for import. Once we're in here, we can easily manipulate the model. We can orbit around the 3D file, and it's pretty quick to just get the viewpoint that you want. We can zoom in. You can see that we hover over the parts. I'm just using the mouse wheel here to move around. To zoom in and out, and then I can hold the mouse wheel down to pan. So very easily we can get the view that we want from an illustrator's point of view. And we'll show how we can get things like isometric easily later on. So I'm just going to bring up the tools menu. So at the moment we see a shaded model, but we also have options to say we might want a wireframe. which might not be too useful, but in certain circumstances you might want to see inside the construction of the particular piece of equipment. Go back to shaded. I also have the option to select a particular part and wireframe that selection. So we can pick out the parts we want to wireframe. And the other mode is something more illustration-wise. If we're going to then take this illustration and export it as a 2D, then we can get a preview of what's going to actually come out as a CGM file. So we can do a quick preview of a hidden line removal illustration. Okay, so let's just go back to shaded. Now you probably noticed on the right hand side we've got our model tree. So we import all that obviously from the CAD system. And if I click on a part here, the fan, it highlights it over on the model tree here. So this is a two-way interaction. So if I click on, say, the exhaust, it's just around the other side, it's highlighted around here, or the intake on the top. So this is two-way that we're working between the model tree. So it's very easy to select the parts on here. So if I go down here, I can select the particular component, and this is part of the main assembly, which in this case is the turbo. So I could just select all of that assembly, and then I'll show what we can do with that in a minute. So quite useful to be able to highlight particular assemblies. So I mentioned things like isometric. So we have preset views. So you could go to the initial view. So we could go back to where we started, or we could begin to look at perhaps isometric. So we preset some isometric views because we believe obviously that's the primary projection now for illustrations. Perspective illustrations is isometric, certainly part of the standards and ones you would definitely use as part of a spare parts catalogue, for instance. And so it's very easy to select those views using the software immediately. So we can also, so I've got the turbo selected here. If I right click, what I can do is I can isolate this. So this means you're opening a new window and we're just working with that one assembly. We can still do the same views as we did before. I can quickly go through the diff to achieve the view that I want. But now I can just work with this one assembly. So you can see on the right hand side that the icons have changed on the other components, so they're hidden. So it hasn't actually deleted them. I can bring it all back and work with them again, but I just want to work with this particular assembly. So a common thing here would be to actually explode this model out. So what I can do is I can do this either automatically, or I can do it manually, or I could do a combination of the two. So I could do an auto and then actually do a manual as well. So in this case, I'm just going to do manual to show how easy it is to begin to work with this. So when I click on the manual tick box, we get this axis. If I hold my control key down, I can just begin to pull these parts away from the main body. So I could pull this, let's say, we'll pull this part away here. We can tape this perhaps to the back. So I think you'll get the idea as I go along. Let's just pull that away there. So once I've achieved the view that I want, what I can do then is I can export that as a CGM. So if I just go down to my choices here, let's say CGM, I'll just put this on my desktop and save. Now I have some choices here. I can do what we call high precision, which gives us the best quality. We can do the line width. We can set a line width we want to do as we export it, or we can it'll just do a auto calculate it. So we have like a low precision, which will do it much quicker, or high precision will give us the best quality, which will give us kind of things like Bezier curves and so forth. So this just takes a few seconds to do. Once it's complete, it will open it directly into VizEx Edit, the 2D version, where we can then begin to work with it to finish it off. So this actually took 15 seconds. Always feels a lot longer. And here's our illustration now into VizEx Edit. So now I've got all the tools associated with VizEx Edit. So I've got my annotation tool. I might want to set my text size here. The call out, let's just make that black. And then we'll start at number 1. So we're not going to go into too much depth in VizEx Edit today. Just want to show you how you would bring this through. So just going around, I'll zoom in a second. Let's just zoom in. You can see that we're getting the numbers. So this would also be able to hotspot the illustration at the same time. There might be some tidying up to do, but in general, we're going to get a good quality illustration. This is just like one arc here, so high quality illustration that then we could still edit if we needed to. We get some extraneous lines. We're still doing some optimization, so we'll be able to get rid of these automatically very soon. So, but there we've gone from 3D to 2D very quickly, spare parts type illustration. Okay, so we could carry on and work with this more if it's not quite right. We can still explode. Say this needs to go vertically down. So you can see how easy it is to work with this. Okay, so I'm just going to reset this. And we'll turn the manual on. So what we've also done is, this is a pretty new feature, but we can now, let's just zoom in a second, select this part, say here, and then right click, and we can modify the color of it. So let's just say we're going to have this blue color. Okay, it's not very apparent until I deselect it, and you can see now that the color we have here. So we could color the actual part. There might be a particular reason that you might want to do that. And we can also right click and we can change the transparency of this as well. So we can make this transparent. Let's say none, and just move away, and you can see that we hopefully can see it's not always that easy with the obviously online that we've now got this particular part with where we can see through the actual thing. We can see through the base and so forth. So what I'm going to do here is one of the other options for export is not only CGM, but we also have image formats. So you may want to take this out purely as a JPEG perhaps with the transparency, and let's save that. And we can select the quality again of the JPEG. So, and that should open in VizEx Edit. Here we go. So we've now got that transparency. We're seeing through the base. We're seeing through to some of the components inside that particular component. So we just want to give you as many ways to get the illustration out as possible, as quickly as possible. So transparency is quite a new feature. So I'm just going to remove the transparency. Okay, and I'm going to go back to tools, and we're going to go back to the initial view. And just move this over here. So the other thing is we're just implementing, this is not the finished iteration of the product here. but we were also doing sections as well. So if I go to X and just reverse this, you can see that we could have a section through this particular assembly. So we could have a section through it, and we could still save that as a CGM. So we've got through the X, the Y, but we can actually change this interface so it's a lot easier for you to use. So we're just working on that at the moment. So this isn't the final iteration of this. So I'm just going to go through here. So let me just go find the view that I'm looking for. So this is like a quarter section through, and we'll actually try and do a hidden line removal on this one. So I'm just going to make this a proper quarter. So you can see the actual section is indicated by the red here. So we can actually now see inside this component. So let's export this as a CGM again. Let's see if we can create a section of this. Let's just rename it. And we'll save that. So I'm going to leave these settings the same. So I think just takes a bit longer to quite a lot of not only doing the section, but it's also doing the hidden line removal. So it does take a bit longer to create the illustration from this. So this particular function is still work in progress, but we are doing this live, so I'm just hoping it's going to cooperate. I did do it a few minutes ago. It was fine. It just seems to be getting held up a bit, but I'll give it a few more seconds before we go. Okay. See if we're thinking about it. Let's see if we can come back to this. Okay, I'm just going to go back to the slides, and fingers crossed that will work in the background. So so that was actually the wrong way around. It's actually 3D to 2D. So VizEx Edit 3D benefits: easy to reuse the 3D CAD data. Hopefully you've seen that. Independent of the engineering or the CAD system. Support of common open CAD formats like STEP and IGES. Intuitive tools to manipulate the model, a bit like a 3D viewer rather than a CAD system. We can isolate assemblies. We can explode the parts for spare parts illustrations. We can convert to 2D format CGM for standards compliance. And we can add quality 2D output into VizEx Edit, where we can add annotations, hotspots, etc. So I'm not sure if that worked in the background. Let's quickly go back. 1 minute 48, and here's our illustration. So really nice illustration of the cutaway, which then we can obviously finish off again in VizEx Edit if you want to add colors to the sections and things like that. Okay, so the next one is we'll kind of try to separate these things out, because there is obviously a connection there, but it's a different requirement. If we're going from 3D to 3D, it sounds a bit strange, but what we're talking about is 3D CAD data into 3D, something which more useful that'd be more useful delivering as part of an IETM, an electronic manual, or on the web. So STEP and I just not really suitable for that. So what are the considerations? Well, just as I just said, I think if you're going to publish these, you really need to choose a 3D file format, and our advice would always be choose an open file format, not proprietary. Things to also to consider is the file size, because that can affect storage of the data if you're having to distribute it, the rendering time, which is also the usability, and also delivery hardware that you want to put this information onto. So from a viewing, you need to really think about how you're going to view these files, what environment they're going to be in. And also, we would say, again, reinforce proprietary is definitely not going to get you on the web unless it's a proprietary viewer, some kind of plugin. So we've kind of focused on 3 formats for VizEx Edit 3D in this initial version. X3D is an XML format, an open format that we're supporting. VRML, which is a well-established format, been in use for years, is open as well. And the latest format we're going to support is GLTF, which is a really interesting format. It's very light, it's open, and it's one that we think has got a lot of potential for the future of delivering 3D on the web, certainly from a technical publications point of view. So we're going to support all those formats: X3D, GLTF, and VRML. VRML is the only one we support also import. We're supporting something called the X3D DOM, which sounds complicated, but basically what it does is it puts the X3D file into a HTML wrapper. The nice thing is it supports the model tree. So and it can have you can have an interactivity between the model tree and the 3D model, which is again a nice thing to have. GLTF, there's also there's also GLB as well. They're the same formats, but they're just encoded in a different way, where GLTF is text and GLB is binary. So the GLB format is very light, very quick to use on the web. So that would be probably a favorite of ours to deliver information, both 3D kind of animations and things like that. So looks good. VRML, we're not kind of discounting that. It's certainly well established, and we wanted to support it. It's very robust, and it did provide the basis of X3D. So they're kind of a family of formats that kind of all work together. So let's go back to the demo. And I'm just going to get rid of this section, and I'm going to show all. So I'll just go back to where we started. So with 3D to 3D, we can export. Oops. There we go. As I mentioned, we've got X3D just on its own. We've got X3D DOM, and then we've got VRML. GLTF is not there yet. We will implement it pretty soon. So let's just cancel that. So I'm just going to go through a similar scenario as before. So just to reinforce, we can isolate this out. We can get the view that we want pretty quickly with our presets. So we can just go through and get the view that we want. We can explode this model off, explode the parts off as before. Let's just do this manually very quickly. And we just pull this away down the grid. So for expediency, what I've done is I've already created this, saved it as a X3D DOM file, and let's just go and look at it in a web browser. So this is the output we get with the DOM. So I don't know if you can see that we get the explosion of the file, but we also get the model tree. So here we can select the parts. So you can see it selected the part in the back there. 13 is that particular part. So we have that interactivity between the model tree and the exploded view. This is not going probably the finished product, but we just wanted to give you a quick overview of what we've got so far. So this is in Google Chrome. So we've got the model, we've got the model tree, and we're creating that straight out of VizEx Edit 3D. So some work to do yet, like for annotations and things, but this is a great starting point, and we'll give you the tools as we go along as we update the product. The other thing that we can do is, let's just go back to tools and we'll reset it. This is one I really like as well, is that the transparency does work in the X3D as well. So this time we'll go through, we'll just change the color again. Okay, and we'll just see that it's done that, yep. And we'll just select this part, and then we'll make this transparent. Okay. And I'm just going to clear the selection, and then we're going to export this. So this time I will do the export as a X3D DOM. So let's just do the DOM here, and we'll make this the transparent. So I'm just going to save this to the desktop, and we'll open that up. So it should create as a HTML file. Okay, happy with that. So it should just give us an indication when that's done. Okay. So let's just go back to the slides while that's working. So the other format that we're going to support soon is GLTF. So I can't actually export a file at the moment, but we will be able to do very soon. We have got a file that we did in the beta version. So what we have discovered with this is that if we just go through to our next slide, that GLTF is native Windows support in Windows 10, and it also got very good support in Google. So with the GLTF, I can actually open in the 3D model viewer that you get with Windows 10, that we can open the GLTF directly in here. So this is one we created, so we can open this directly in the Microsoft viewer. So it's pretty impressive that we can open that, and these are supporting the things. So okay, we also can drag and drop this onto a GLTF file onto here. So we should have the GLTF file on here. So we can drag and drop that onto here as well. So this is part of Google. So we've now got the model in Google Chrome as a GLB file or GLTF file as well. So I just wanted to give you a quick overview of what we're looking at from a file format point of view. So let's just see if we did create that file for the thing, and obviously it didn't work, unfortunately. So we'll actually put that up on the web. So as I said, some of the things we're doing are still in beta. Others are obviously complete, and that will be in the finished version. So to summarize, Larson, we are making some significant progress in supporting the 3D file formats. That's conversion, compatibility, and compliance are our keywords, and always will be. We continue to develop standards compliant technology. We're going to the product roadmap continues to mature, both 2D and 3D graphics, and it's a significant part of our strategy going forward. And we're pleased to work with any companies or organizations interested in implementing 2D and 3D graphics. So I think Don's going to rejoin us at this point to do some Q&A. So Don?
Yes.
So
okay.
We have some questions. First question is here: SolidWorks Composer has the same features converted in 3D. Has your software? How is this your software agile to use in terms of time saving and quality? So difficult to compare to the SolidWorks Composer. I think the advantages that we have over it are, or will have over it, is that we have a 2D component where we can add annotations and hotspots and save a CGM file. I don't know if, would you agree with that, Don?
Yes, that's one thing that stands out different. We've integrated with a 3D editor, with 2D editor, excuse me. And so there's quite a bit of flexibility that we've got there. Now, there are some things Composer does that we don't do yet, like animations, but that is on our roadmap too. So I've not worked directly with Composer. I've seen many demos. It's a nice product, but I would say ours is a little more intuitive. Well, I don't know. That's maybe a perspective, but I think that the 2D integration is obviously ours is also open standards, and so that's how I think the summary of it is.
Yeah, it's always difficult to compare to existing programs. There are other pieces of software out there that do what we're doing, but we've really tried to make this as easy as possible from an illustrator's point of view, and make that as cost effective as possible. So all the software you've seen today is open for evaluation. So if you want to evaluate the software, just give us a call or send us an email, and we can make that available to you to evaluate with your own files. Next question is, there's two connected questions, is can we give a call out on a JPEG image and hotspot too? And hotspot that as well? And the answer is yes. Because we're in VizEx Edit, we can annotate as we did with the spare parts illustration, and we can add a hotspot to that as well. So that's with a JPEG, and then you could actually still save that perhaps as an SVG or as a CGM, probably not the CGM, but certainly the SVG. Or could it be a CGM as well, Don, with a JPEG? I think it could, couldn't it?
Yes, certainly. Yeah, and if yes, and there's we can hotspot. And the next question is hotspot too. Somebody is, it's a good follow-on question there, but yeah, we can add the hotspots. And certainly if you hotspot, then you have to do CGM or SVG. But you could put the call out on a JPEG and save it as a JPEG, for instance. But anyway, I think it points out the flexibility in our solution is that there's a lot of 2D capabilities that are available.
Yeah. Next question is, can we on the section, can we exclude inner parts from the section? And the quick answer to that is yes, because what we didn't show is that we could actually hide parts as well. So we can exclude them from the section. So the answer is yes, we could do that. Can we give a call out on 3D output. Not currently, but that's something we're looking at, is the call outs on 3D output. So something on our roadmap, as Don would say, but at the moment we can't do it directly, but it's certainly something we're looking at. We obviously know that's necessary. We do support the model tree. Have you a comment on the call out situation, Don, in the 3D?
Yeah, that's certainly on our roadmap, and yeah, that's something we've thought of too. And the formats that we publish through GLTF, X3D certainly facilitate 3D annotation, where type of annotation where it's sometimes it's called billboarding, where it's kind of anchored as you rotate around. The annotation stays flat in your view. So so that's a good question. Yeah, we're definitely on our roadmap.
Yeah. Somebody said, good presentation. Which language for X3D DOM is used? Don, anything on that?
Yeah, well, that is a good question. X3D DOM is technically not a format. It's a name we put on. We actually make an X3D and then wrap it in HTML with a little bit of JavaScript in there to connect it up. So X3 DOM is essentially HTML with XML, X3D XML graphics internally. And so yeah, that's a good question. But it's compatible with any browser. So when you export it, it's ready to go, boom, in your browser, and you can view any 3D part in there.
Yeah. Yeah, there's a lot of work to do. This is the first version of VizEx Edit 3D. So we've done a lot of work on the 3D to 2D conversion, and there's a lot of work to be done on the 3D to 3D. But we want to make that as as cost effective as possible. So we just want the user to be able to say export, and it exports it with all the requirements they need, without having to do too much on the back end. How many tries can soft handle run user without graphic card? I'm not sure.
I'm thinking maybe it means triangles.
Right, for the size of file. Perhaps.
Yeah. Well, it can handle very large files. I mean, the languages that we're using, GLTF especially, is just super fast, and you can just do really big 3D models because it goes right to the GPU. GLTF is optimized to go right into your GPU processor and very extremely efficient file size and performance.
Yeah.
So
yeah, I think it's certainly an impressive format, and that's probably why Microsoft and Google have selected it really for 3D. There's a lot of potential there for delivering certainly publications in our arena, where different platforms are used, like mobile platforms like iPads and desktops and laptops. So performance is essential. So, and this is the thing you have to consider when you're delivering 3D. It's not only the file; it's what platform you're going on to. What hardware is the user going to be have at their disposal.
Yeah, and that brings up a good point too. The GLTF is going to be really, really fast with mobile devices, iPads, and Android devices. So
so what I would suggest is, if you're interested in looking at using the software, just come to us for an evaluation and try it with your own files. That's probably the best solution. If you got STEP or I, just bring them in and then export them, X3D or GLTF, and you'll see the performance. GLTF is just a lot easier to do because of and we'll support that. That's one of the questions I have here is when will you implement it? And Don, would you want to answer that? When will we support GLTF? Say within the evaluation?
Very, very soon. It's in development. I've seen some of the alpha versions of it. So yeah, in almost
within the next few weeks?
Days instead of weeks almost, but
okay.
certainly before the end of the year.
Yeah,
it'll be published, in the next 2 to 3 weeks.
Yeah, so really anybody using Windows 10 is going to be able to bring in a GLTF model or GLB model, and also with the Google platform as well. This is again really impressive what you can do within Google with GLB, which is the binary format. So yeah, we're really focused on this, and we got any more questions? So is the trial version available for a personal computer? Well, yeah, our trial version is, when I say personal computer, it's any Windows platform. We don't support Macintosh. Another question here, Don, not quite sure. What are the menu languages X3D will be provided with? Did you hear that? Not really sure what that means.
Yeah, I guess unless we're talking about the annotations, what language the annotations will be in. Of course, we take the stuff right from the STEP file. So a STEP file supports, supports all languages. So
exactly, yeah.
So certainly there, if it's available, we'll export it.
If there's a language in the model tree, then that's what will be exported, if that's the question. If the person wants to send us an email, perhaps, and probably outline that in a bit more detail, we can take that offline.
Yeah, it does point out one thing though, since we'll be taking, we take the model tree, the parts names and stuff right from the STEP file now, and it goes directly into XML. Now, translation could be done then easily in the XML.
Yeah,
that would be the benefit of XML. So I think you pointed out a reason to use XML, for instance, because you would have access to the text for translation. So
okay. All right, thanks, Don. Thank you for all the questions. Good questions, and thanks for interacting with us today, and we hope you've enjoyed the presentation. I think we've been going an hour, so a bit longer than we planned, but it's good that we've probably answered the majority of questions you have. If you still have more, please contact us, and we'll try and help you. So you can email us, and we will respond as quickly as possible. As I mentioned, the eval version, you can approach us for that as well. We can send you that, and you can evaluate the software with your own files. But just to end, so thank you for supporting the webinar today. Thank you, Don, for helping with the questions. We hope you have a great holiday, and a very safe holiday, and a fantastic 2021. So thanks if you've attended a webinar before, thanks for supporting us this year, and we'll look forward to speaking to you again next year in our next webinar. Thank you.